All right, unit 8. Pretty easy unit to finish the semester up. It's on areas, most of the areas, some perimeter stuff. 8.1 is on rectangles and squares. A lot of you know what area is already. It's the measure of the interior region. Measure of the interior region. Measure of the interior region is amount per area. So if you're looking at this picture right here, I drew a rectangle on here. I put it on graph paper so that you can actually see how many little squares would fit inside. And area, of course, we measure it in square units. So this one right here represents 1 square unit, 1 unit by 1 unit. So if you look at this picture right here, this side right here is 7 units. It's got 7 rows. And this down here has 14 units. It's got 14 columns. So you could say that you've got 7 rows of 14 each, or you could say you've got 14 columns of 7 each. Either way, you're going to find your area of this figure is going to be a 14 times a 7, which is a 98 square unit for this figure right here. We've got a couple of formulas. The one we just used is the area of a rectangle formula. The area A of a rectangle with base B and a height of h is just b times h, or base times height. That's for every rectangle. Now, if I wanted to find the area for this square that I just picked out of that little picture over there, area of a square would be base times height also, but they're both the same. They're both 1s. So really it's 1 times 1, or 1 squared. So you could actually put that the area of a square, area A of a square with sides of s, would be area equals s squared. So side times side would be side squared. S times s would be s squared. So for the rectangle, it's base times height. For the square, it's going to be side times side, which is side squared. Now notice up here when I put area basics, I just said it's the measure of the interior region of whatever shape you're using. Then here at the bottom, I put the area of a polygon. So why would I put polygon down here? What's a polygon going to be? Not 4 or more, 3 or more sides. 3 or more sides, but what do we know about the sides? Polygons have to be closed, and can they have curves? No, got to be straight. So polygons have all straight sides. So the area of a polygon is the number of square units in the region bounded by the polygon, inside of the polygon. The number of squares that we could fit inside of the polygon would be the area of a polygon. Now, when you see mystery word or mad gab or stuff like that, you don't have to write that on your notes. I'm just throwing little things in to lighten it up a little bit. So, a mystery word, I'm going to click on it, and it's going to bring up 5 words. I don't know if you've ever played Taboo before, but you've got 5 things you cannot say to try to figure out, and that one word is on the top. Well, what I did is I picked the 5 words and put them on the board, and you got to figure out what the top words would have been from those 5 words. So basically, what are these 5 words describing? Okay, so if you think you know it, raise your hand, and I'll call on you and see if you get it right. So here's the mystery word. Here's the clues. Arrow, line, parallel, forward, flush. What mystery word would be on the top of the card if those were the 5 words that you couldn't say? Maybe. Maybe. Gotta have your hand up. What? What did you say? Ray. No, it's not Ray. Straight is correct. Straight as an arrow, straight lines, straight parallel, straight forward, a straight flush. Straight is correct. I do have candy, so I give out candy for a right answer. Okay, moving on. All right. Here's our example. Throughout the pages, you'll see a few other things, or one more today, I think. We'll have more tomorrow and stuff. Tomas is estimating the cost of replacing the carpet in his living and dining room. He measures the rooms and writes the dimensions on the sketch. How many square feet of carpet is needed? If the carpet he chooses is $2.49 a square foot, how much will it cost to carpet these two rooms? And that's a big push here, is to be able to take what you learned about area and apply it to how much things would cost, being able to figure out the total cost of something. So first thing we would probably do here is, this is not a normal area or, a rectangle or a square. So could I make it a rectangle or a square? I could if I drew one line in right there. Now what did I just do? I made a square and a rectangle. Here's my square, 10 by 10. Here's my rectangle. So I got a 10 by 10 square here, and I got my rectangle over here on the side. So now I can find the area of each one and just add them together. So what's the area of the square dining room? Has an area of 10 by 10, which is 100 square feet. So 10 by 10 is 100 square feet. The living room is rectangular. And the rectangular living room has an area of 12 by 24. Now we got to notice how we get the 12 by 24, because I don't see a 24 on the picture. But if I'm looking at this piece from here to here, I've got 14 units that goes from here to here, and then I got 10 more right here. So 14 and 10, that's how I get the 24 feet. So that whole side of that rectangle would be 24 feet. So you're looking at a 12 by 24 rectangle. So the area here of my dining room was 100 square feet. The area for my living room was 288 square feet. Together, what's my total area? 388. Yeah, 388 square feet would be the area when you add 100 plus the 200 to get 388. Now, you're not done yet, though, because what is it asking? The cost of the carpet. It's telling you that carpet's $2.49 a square foot. So you're going to need to take your cost, your 388 square feet, and multiply it by $2.49 each. Each square foot is $2.49. So that's some expensive carpet, but there are some expensive carpets. There's carpets that are more expensive than that. So $966.12. So carpeting 388 square feet could get expensive, depending on what kind of carpet you want to put in. And that doesn't count the padding that goes under it, and carpet strips that you got to buy, and installing. So that's just the carpet itself. So it gets expensive when you own your own house or whatever. You got to put all that stuff in. So it can get expensive. All right, can we move on? Are we good? These are ones that you'll see later, kind of. Some of them in our notes, some of them on practices, and some on the homework. Okay, so $966.12. Now I've decided this week to print your notes, so I'll give you just a break from having to print stuff. If you are absent, or if anybody knows Katie and she's absent today, you can let her know that the video will be put up online as well, so she could watch it if she needs to. She wants to print. The printed version will be online as far as the filled-in version. I'm not putting online the filled-in part. So. All right, moving on. Here we go. We got perimeter and area this time. Perimeter and area of the figure with the given coordinates. So we want to plot these 4 points. So if I went over 4.5 and up 3, that would be like right over 4.5. 1, 2, 3, 4.5, and up 1, 2, 3, right here. And then my other point would be here. Find it. Oh, there's somewhere. There it is. There it is. There it is. There's the 4 points. Those 4 points right here, we graphed on our graph here. It made a polygon. Actually made a quadrilateral. We want to find the perimeter of that and the area of that. That's a big push also, being able to plot points, find the perimeters and the coordinates of the shapes that you get when you plot those points. So let's see, the first part that I want you to write in is that the little triangle on the y represents our height. That is the change in y. That's going to be this amount right here. Okay, that's that amount. That's our height. That's how much this y is changing to get up to this y, or vice versa, this one down to this one. So what we want to do then is we want to subtract our y coordinates. Two of our y coordinates are 3's. The other two y coordinates are negative 6.5's. So I'm going to take the 3 right here, and I'm going to subtract the negative 6.5. Why am I what? I'm taking the one coordinate and subtracting the other coordinate to find out how far apart they are. I want to know how far apart those two are. So when I subtract those two, since it's a double negative, you make it pluses and you get positive 9.5. So that means that this right here is 9.5 units. And you could even count it, because it is vertical. So you could say, well, let's see, I'm going up 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So you could have actually counted 9.5 units on your actual paper. And you could actually do that for the x also, which represents our length. The change in x represents the length. So you could actually count across. In this case, you've got a negative 5 way over here. You're subtracting a positive 4.5. Negative 5 minus a 4.5 is going to give you negative 9.5. But you're supposed to have absolute value signs in here because distance is always positive. So you got your absolute value signs to make it a positive 9.5. So that means this is also 9.5 units. So what kind of shape do we have in our picture here? We have a square, right? So how do I find the perimeter of a square? Yeah, since the figure is a square with a perimeter of 9.5 times 4, because all 4 sides are 9.5. That's going to give you 38 units. So if you started in this bottom corner and you walked all the way around and ended up right back where you started, you would have walked 38 units. That's called the perimeter of the shape. You're walking all the way around the figure. Because distance is always positive. If I come up with a negative number, I can't have a negative distance. So I'm using absolute value to make sure that this amount right here is positive amount. That is also a positive amount. So. Now what about area for that square? Base times height, or side times side. 9.5 times 9.5, which would be 9.5 squared. So since the figure is a square, area is 9.5 times 9.5, which is 90.25 square units. What that means is that if you counted all the squares in here, 2 halves would make a whole. As you counted them all, you get 90.25. Where's your quarter square? You see this little piece right here? That's where your quarter would be. This is a quarter of your square. That would be your 90.25. So all the rest of them went out up to 90, and then you got that little 0.25 right in that area right there. So 90.25 square units would fit inside of this square. We do have a mad gab. You guys remember mad gabs? Or anybody know what a mad gab is? When you say words really fast, and then you think you know what it is, you raise your hand and you tell them. Okay, first one to raise their hand. Anyone? Get that. Go. Right there. The sound of music is right. These hound off music. Music. So if you say this fast, these hound off music, it sounds like the sound of music. We'll throw those in every once in a while just to make it a little interesting. All right, moving on. Moving on to some practice ones. Okay, here's number 1. Here's number 2 below it. Here's number 3. I'll give you about 2 minutes. So number 1, we broke it into 3 times 10, which is 30, and 5 times 4, which is 20. Added 20 plus 30, got the 50. Okay, try number 2. Check it out. I would probably put in a line straight here, and then I'd put another line going up here. You could have done a cross. Would have been the same thing. I would start small here. I know that the whole thing is 16. I got a 6 plus another 6. That's how much? 12. So what's left over? 4 units. So this is 4 units right here, and that means 2 times 4 is 8 square centimeters. Now I've got a 6 times 4 plus 2 is another 6. So that's going to be 36 square centimeters. And then now I've got a 6 times a 12, which is 72 square centimeters. So we're going to add 72 plus 36 plus 8, and you're going to get 116, which is correct. That is your total area. Okay, so look for the area of the shaded part in number 3, just the shaded part. Okay, so we've got the shaded area. To get the shaded area, the plan of attack would be to get the whole area, the whole big square, and then pull out the shaded part, or the white part. If you pull out the white part, pull out this part, the only thing left would be the shaded part. So the area of the whole thing would be 15 times 15, which is 225 square feet. The area of just the white part would be 10 times 10, which is 100 square feet. The area of the shaded part would be the 225 minus the 100, which is 125 square feet. So you was right. That was your shaded part. Okay, I do have one review problem on the page for you. Here it is. Draw that one on your paper. It is a 45, 45, 90. 45, 45, 90 right triangle. And a leg is 9 radical 2, and your x is on the hypotenuse. Just take a second, see if you can remember what x would equal. There's not really much work to show on this one. The formula was to take your leg and multiply it by radical 2. That will equal your hypotenuse. So you could take the 9 radical 2 and times it by radical 2. You would get 18. Because radical 2 times radical 2 would be 2, and 9 times 2 would be 18. So 18 would be your x, would be 18 right there. All right, moving on. Just review. I guess we're going to need to review those because 45, 45, 90s are important. 30, 60, 90s are important. How do you go from the short leg to the hypotenuse? To double it. How do you go from short leg to long leg? Multiply by radical 3 this time. Radical 3. Okay, moving on. Hopefully you've got those. Okay, draw the figure with the given vertices. You might have already drawn it on your paper. If you haven't, you should draw 0, 0, a 6, 0, a 6, 3.5, and a 0, 3.5, and connect those. And you would have a rectangle. You would have a rectangle. You need to find the perimeter and area. Perimeter and area. So I'll call on one person for perimeter, and I'll call on somebody else for area. There was example one we did like this too. So we did an example just like it on the other side if you need to remember it, but you might be able to just count because it's horizontal and vertical lines should be easy just to count. So perimeter and area should be pretty easy, I think, but we'll see. Joshua Feldman. Perimeter when you're done. You have the perimeter? Almost, okay. Let's see if he's right. How much is the height? 1, 2, 3 and a half. So they're both 3.5. How much is the length? 6, and that's 6. So you got 12 for the two lengths. You got 7 for the two heights. So your perimeter equals 19 units. That is correct. Okay, let's go with Mahim. What's the area? It's not a square. Yep. You don't have it. You're working on something else, it looks like. Jose Ramos. What? 19.5. No. What? Jose. 21 is correct. 6 times 3.5 is 21 square units. I think you should do this and not whatever you're doing. All right, find the area. Well, the area of a square field is 625. A little bit different on this one. Let's work this one out together real quick. Area of a square. So what do we know about the area of a square as far as the formula goes? It's on your other side of your paper. What's the area of a square formula? Side squared. So I would put that first. Fill in what you know. What do we know? It says the area is 625. So that's going to go in the A part. 625 equals S squared. How do I get S? Just simply square root both sides. So your S is going to be the square root of 625, which is 25. Now, what does that tell me about my square? Square with what? With all equal sides being what? They're all 25s, right? All 25s. So what's the perimeter now? 25 times 4 would be 100. And that would just be yards. Not square yards, just yards. You went from the area to the perimeter. But to get from area to perimeter, what did you have to find first? The side. You had to find out what the sides were. To get from area to perimeter, you needed to find out what the side was, and then you can get to your perimeter. Okay, so there is page 5. We got one last page here. Hopefully you got these okay. Okay, the shape of Wyoming is nearly a square. Not exact, nearly a square. So we'll draw a square on our paper. It says the land area of Wyoming is approximately 100,000. I'm going to put that inside because that's what we call area. It says, are the approximate dimensions of Wyoming? I'm going to set this up just like I did last time, because it's telling me the area is 100,000. It wants to know what the sides are, what the dimensions are. So what are we going to do to get that answer here? Square root. Now that's not going to come out to be like 100 or 1,000 or anything. That's going to actually be how much? Good. 316.2 approximately. And that's miles. 316.2 miles approximately would be all four sides. That would be your sides of Wyoming. So Wyoming sides are about 316.2 miles, not exact, but roughly. Okay, sod comes in rectangular patches that are 3 feet by 6 feet and cost $4.50 each. If you resod a section that is 10 yards by 15 yards, how much will the sod cost? What do I need to do here? Yeah. The approximate dimensions is just because this 100,000 is not an exact number. So we square root that, you're going to get approximately 316.2 on each side. It's not an exact number. You might drive it in Wyoming, and you might get 320 miles, but it would be close. Okay, what we have here is we have a piece of sod that is a rectangular piece of sod. We have a garden that we are going to resod. So we've actually got two rectangles. Yeah, the sod is 3 feet by 6 feet, and the garden is 10 yards by 15 yards. I need the same unit. I don't want one in feet and one in yards. So should I do it all into feet or do it all into yards? In this example, yards would be okay, because this comes out nice and easy, 1 yard by 2 yards. If it didn't come out easy, then I would go to feet. Normally you measure stuff in feet around the garden anyway. So, but in this case, it would come out nice and easy. This is going to be 1 yard, and this is going to be 2 yards. So my area would be 2 square yards, because 1 times 2 would be 2. This is 10 yards, and this is 15 yards. So my area is 150 square yards. The question then is, how many of these pieces of sod do you need to fill up this whole garden? How do I figure that out? How many pieces go into the garden? You got to divide. You got 150, and you got to divide it by 2 because each one is 2. So it's going to be 75 pieces would fill up the garden. 75 pieces times how much is each piece? $404.50. Not cheap. You need 75 of those. So somebody on your calculator multiply 75 times $4.50. $337.50. That's not including tax. You'd have to even pay more if you were buying sod at the store. So 337.5 is what you'd need for the pieces. Now, would you buy the exact amount? No, you'd buy a few extra. You don't want to be short, or some of them get messed up and you need a few extras. You'd always buy a couple extras. That's that one. Now, rectangular room in a house measures 9 feet by 16 feet. Okay, so it's a rectangular room. So we draw a rectangle. It's 9 by 16. So how much is the area of that room? What? Okay, 9 times 16 is 144 square feet. There's another room in the house. There's another room in the house that has the same area, but one of the dimensions is 12. They want to also get 144 square feet. So what would the other dimension have to be of that room? Have to be a 12 by 12 room. Because this room would have the area of 144. This room would have the area of 144. They'd have the same area. Okay, last one, a little challenging. I want you to see if you can draw a picture of that. I'll give you a couple minutes, see if you can draw a picture. The sidewalk is all 2 meters. Just around the whole, this is 2 meters from here to here. This is 2 meters, this is 2 meters, that's 2 meters. This is 20 meters. And this piece is 12 meters. So from here to here is 12, from here to here is 20. So you've got the garden here, so this would be the grass and stuff like that. That's your garden. Then you'd have your concrete sidewalk around the outside. Pretty wide sidewalk, about 6 feet wide. 2 meters is about a big sidewalk. That's just what I wrote down for the problem. They want you to find the area of the shaded part. How do I do that? Okay, so you add 4 because this whole thing would be a 2 plus a 12 plus another 2, right? So 4 plus the 12, this whole thing is how much? 16. This whole bottom piece, 20 plus 4, 24. You're right. So the whole area would be 12 by 24, no, 16 by 24. Sorry. So the whole area would be 16 by 24. Anybody have that number? 16 times 24? 384. Okay, the garden would be 12 by 20. So that's going to be 240. So your sidewalk would be the 384 minus the 240. Yeah, 144 square meters, not feet. So 144 square meters would be the sidewalk area. All right.